Welcome to the fundamental section on getting started with data quality. Here, we'll cover what data quality is, why it matters, and the key roles involved in ensuring it. What is data quality? Imagine a delicious recipe. You gather all the ingredients, follow the steps meticulously, but then you realize you used baking soda instead of sugar. Data is similar. We collect information, analyze it, and use it to make decisions. But if that data is inaccurate, incomplete, or inconsistent, our results will be as disastrous as that burnt cake. Data quality refers to the overall health of your data. It encompasses factors like accuracy, is the data free from errors and typos? Completeness, does the data have all the necessary information? Consistency, is the data formatted uniformly throughout? Timeliness, is the data up to date and reflects the current state? Why is data quality important? Think of data quality as the foundation of your decision making. Imagine a company relying on inaccurate customer addresses for a marketing campaign. Wrong mails, wasted resources, unhappy customers. The fallout from this scenario doesn't stop there. These issues can snowball into even bigger problems for the company. Businesses lose as much as 20% of revenue due to poor data quality. So, poor data quality can lead to misleading insights and ineffective strategies. Furthermore, inaccurate information can erode customer trust. Like I quoted before, imagine spending money on marketing campaigns targeting the wrong audience. Every year, 25 to 30% of data becomes inaccurate, leading to less effective marketing campaigns. Conversely, good data quality unlocks a treasure trove of benefits. What are they? Confident decision making. Accurate data empowers you to make informed choices. Improved efficiency. Clean data streamlines processes and saves time. Enhanced customer experience. Accurate data allows you to personalize services and build stronger relationships. To summarize, data quality is the cornerstone of any data driven initiative. By prioritizing data health, you ensure your data works for you but not against you. In the next episode, we'll see who ensures data quality and what skills they need to succeed. In today's data driven world, data is the new oil. But just like dirty oil can't power your car, messy data can't help businesses make good decisions. That's where data quality professionals come in. They are the data detectives catching anomalies upfront and making sure information is accurate and reliable. There are two key roles here: data quality engineers and data quality analysts. Engineers focus more on technical needs, while analysts work closely with business needs, but their duties often overlap. While roles like data analyst often steal the spotlight, a critical yet often overlooked role is that of a data quality professional. As businesses increasingly rely on high quality data quality roles are growing in demand, offering great potential for career advancement. Whether you are experienced in data or just starting out, learning what data quality professionals do might spark your interest in this role. So let's delve into their key responsibilities. The ones that I'm going to cover now are the core job duties of both data quality engineers and data quality analysts. It begins with data profiling and analysis. Conduct in depth analysis of data to identify patterns, anomalies, and potential quality issues. Assess data characteristics like data types, missing values, outliers, and inconsistencies. Employ data analysis and visualization techniques to identify data quality issues. Next, data validation and verification. Define and enforce data validation rules to ensure data accuracy and consistency. Cross-reference data with other sources to verify accuracy. Perform manual reviews and use automated validation tools. Root cause analysis. Investigate the root causes of data quality problems and recommend solutions. For example, if data inconsistencies appear, they investigate whether it's due to system issues, user error, or integration problems to work on targeted fixes. Data cleansing and standardization. Correct errors, remove duplicates, and handle missing values. Standardize data formats, normalize data, and apply consistent naming conventions. Implement data cleansing and standardization processes to improve data quality. I would like to add a note here that this data cleansing task is often an optional one. Why? Because it depends on the organization's data architecture standards. Recently, many architectures are designed to correct inaccuracies directly at the data source rather than in the intermediate data layers. In such cases, data cleansing may not be a mandatory responsibility for a data quality engineer or analyst. Moving to the next one, data quality monitoring and reporting. Establish metrics or KPIs to measure data quality because you can't improve what you can't measure. Set up automated monitoring systems to track data quality metrics. Generate regular reports on data quality metrics and trends. Business stakeholder engagement. Work closely with the business stakeholders to understand their data needs and communicate data quality insights to the stakeholders. Last but not the least, again one more optional task, that is data governance and metadata management. Enforce data governance policies and standards, maintain accurate and up-to-date metadata, assist in populating and maintaining data catalogs. This responsibility can be an optional for data quality professionals as it often depends on the organization's data governance framework. In some cases, dedicated data governance teams handle these tasks, while data quality roles may only support as needed. That's why this could be an optional activity. So far, the responsibilities we have discussed are common for both data quality engineer or data quality analyst. However, the additional job duty of a data quality engineer is automation and tool development, where they are responsible to build and maintain data quality tools and automation scripts. Some organizations procure data quality tools like Informatica, Talent, Collibra, etc., while others choose to build in-house automation frameworks. This automation task comes under data quality engineering pod over an analyst responsibility. So with these responsibilities, data quality professionals help build a reliable data foundation. Now let's explore the qualification you'd need to excel in this field. Companies do expect a bachelor's degree in computer science or data science or any related field. Previous experience in data analysis or data quality roles is expected. Talking about the technical skills, it is required to have strong understanding of data quality dimensions and metrics, data profiling and analysis, hands-on experience with data quality and observability tools like Collibra, Monte Carlo, etc. Any one of these tools should suffice. Proficiency in SQL. Companies often list their preferred databases such as Snowflake or Amazon Redshift. But there is no strict requirement to know these specific tools. Having expertise in other similar ones will also be acceptable. Familiarity with data governance, data management, data classification, data cataloging, and data lineage. Understanding ETL processes and data integration concepts. Knowledge of programming or scripting languages like Python or R for automation and analysis. Familiarity with the cloud data platforms like AWS or Azure or GCP for cloud based data management. Besides these technical skills, soft skills like strong analytical and problem solving ability is expected to have. That's a wrap on the job responsibilities and required qualifications for data quality professionals. In the next episode, we'll compare the key roles, ETL testers, and data quality engineers to understand how their responsibilities differ. Are you confused between an ETL tester and a data quality engineer? While both roles work with data and quality, they have slightly different responsibilities. In this video, I'll break down their key differences, skills required, and which one might be the right fit for you. Alright, what does an ETL tester do? As you are already aware, ETL stands for extract, transform, and load. So, ETL testers ensure data is correctly extracted from sources, transformed as expected, and loaded accurately into the data warehouse. They focus on validating data movement from source to target, checking transformation logic, ensuring no data loss or corruption, performing performance testing on ETL pipelines. Common skills that is required for ETL tester is SQL and programming languages like Python for automation. What does a data quality engineer do? A data quality engineer ensures that data is reliable, accurate, and fit for business use. They work beyond ETL validation and focus on data completeness, accuracy, consistency, and timeliness. Their responsibilities include defining and validating data quality rules, implementing data quality metrics like accuracy, completeness, consistency, and timeliness, performing data profiling and anomaly detection, automating data quality monitoring. And the common tools data quality engineers use are the data quality tools that are available in the market like Colibra, Informatica, or Talent, and data quality frameworks like Python Great Expectations for automation, and of course, SQL. Here is the summary of key differences. Which one is right for you? If you enjoy testing, debugging, and ETL workflows, ETL testing might be for you. If you love data accuracy, monitoring, and governance, becoming a data quality engineer is a great fit. If you're open to both roles, that's absolutely possible as they share transferable skills and a strong quality driven mindset. Finally, both roles are essential in ensuring high quality data pipelines. If you are starting in the data space, understanding both can help you decide your ideal career path. In the next episode, we'll look at the most common data quality challenges these professionals face. Why should you know about this? If you don't understand the problem, there is no way you can address it, right? So let's break down these issues to better understand them. Now, what are the most common data quality issues? They can be duplicate, inaccurate, ambiguous, hidden, inconsistent, stale, and orphaned data. Let's get to what each of these signifies. First one, duplicate data. Companies today are bombarded with data from everywhere: their own computers, online storage, and constant updates. On top of that, their data might be scattered in different programs and systems. This can lead to a lot of same information being stored in multiple places. For example, imagine having the same customer's phone number listed twice. This can make things confusing for both the customer and the company. Marketing campaigns might miss some people or accidentally contact others too many times. Having duplicate data can also mess up important reports and even lead to problems with creating software that relies on that data. But what are the root causes for the duplicate data? Data silos. When information is stored in separate systems that don't communicate well, the same data can be entered multiple times. Next, human error. Simple typos or mistakes during data entry can create duplicates. Also, inconsistent data entry. If customer information is entered differently each time, say for example, John Smith versus J. Smith, it might be seen as separate entries even though it is the same person. So that's where duplicate data stems from. Next one, inaccurate data. For some businesses like hospitals, having super accurate data is extremely important, especially during health crises like COVID-19. If the information is wrong, it's impossible to get a clear picture of what's happening and make the right decisions. The same goes for regular businesses. If customer information is inaccurate, it is difficult to give them the best service and target them with the right marketing campaigns. There are a few reasons why data can be inaccurate. Sometimes people make mistakes when entering wrong information. Also, data can change over time, like an address or phone number. Experts say that a surprising amount of data, around 3% every month, becomes outdated worldwide. Moving to the next issue, ambiguous data. Not all data problems are about having too much information. Sometimes data can be confusing or unclear. This is called ambiguous data. Here is why data can be ambiguous. Abbreviations. Using abbreviations without explanation can be confusing. For example, CA could mean California or certified accountant. Likewise, missing context. Data might be missing important details that clarify what it means. For example, a date might be listed without specifying if it's the start or end date of something. Similarly, inconsistent formatting. Inconsistent formats for dates or addresses can make it difficult to interpret the data correctly. Now let's talk about hidden data. Data is not always easy to find. Sometimes important information might be buried within other files, documents, or even entire systems that are no longer actively used. This is called hidden data. Here is why data can be hidden. Data silos. Different departments or teams within a company might store their data in separate systems that don't communicate well. This can make it difficult for other teams to access and utilize the data. For example, customer data available within the sales team might not be shared with the customer service team. This hinders their ability to create a complete picture of the customer. Similarly, embedded files. Data can also be hidden within documents like spreadsheets or presentations. For instance, a chart might contain additional data points that are not visible in the main view. Legacy systems. Older computer systems might store data in formats that are difficult to access with newer software. These data graveyards can hold valuable information that's simply not being used. Lack of documentation. Without proper documentation, it can be hard to know what data exists, where it's located, and how to access it. Let's see what is inconsistent data. Even when data is found and accessible, it can still be problematic if it's not consistent. This means the same information is presented in different ways throughout the system. For example, A customer's address might be listed as 123 Main ST in one system and 123 Main Street in another. When you're working with multiple data sources, it's almost inevitable to encounter such mismatches in the same information. Data inconsistencies can result in erroneous financial reports impacting decision making. Here is why data can be inconsistent. Different data entry formats. If data is entered in different formats across various systems, example, dates in YYYY MMDD versus MM/DD/YYYY, measurements in meters versus feet. These differences will make it difficult to analyze and compare data accurately. Missing standards. Without clear guidelines for how data should be entered and stored, inconsistencies are bound to arise. For instance, some systems might use abbreviations for states while others spell them out entirely. Manual data updates. If data is updated manually in multiple places, there is a higher risk of inconsistencies creeping in, especially if updates are not done consistently. This can be particularly problematic during data migration or company mergers where information from different sources need to be combined. Lack of data validation. If systems don't have checks in place to ensure data conforms to specific formats or ranges, inconsistencies can easily slip through the cracks. Inconsistent data can lead to inaccurate reports, flawed decision making, and wasted resources. Just like data driven organizations keep a close watch on data consistencies, it's crucial to reconcile these inconsistencies to ensure your data remains trusted and valuable for powering your analytics. Next comes stale data. Data is not static. Information can change over time, such as customer addresses, phone numbers, or product preferences. However, data does not always get updated regularly. This can lead to stale data, which is information that is no longer current. Here is why data can become stale. Lack of update processes. If there are no clear procedures in place for updating data as it changes, it will inevitably become outdated. Data silos. Information stored in isolated systems might not be easily accessible for updates. Customer churn. When customers leave or stop interacting with a company, their data may not be deactivated or flagged as outdated. Stale data can lead to misleading insights, ineffective marketing campaigns, and frustrated customers. By implementing regular data refresh processes, companies can ensure their information remains accurate and up to date. Last but not the least data quality issue, orphan data. Data does not exist in a vacuum. Often, pieces of information are linked together to provide context and meaning. For example, a customer record might be linked to their purchase history. However, sometimes these links can get broken, leaving behind orphan data. Here is why orphan data can occur. Deleted parent records. Imagine deleting a customer profile from our system. If the system doesn't properly remove or update any associated data, like their purchase history, that information becomes orphaned. It's still stored somewhere, but it's no longer connected to the original record it belonged to and becomes unusable. Incomplete data migration. When moving data between systems, some information might get lost or left behind. This can result in orphaned data points that are no longer linked to the original source. talking about system changes, if the way data is stored within a system changes, previously linked data might become orphaned if the connections are not updated properly. Orphaned data can waste storage space, clutter databases, and make it difficult to get a complete picture of the information you have. By regularly reviewing and cleaning up your data, you can minimize the risk of orphaned data and ensure your information remains well organized and usable. To wrap it up, data quality issues can cripple businesses across various industries. From inaccurate reports to frustrated customers, the root causes spanning people, processes, and technology can have a significant downstream impact. But the good news is, by understanding these common pitfalls, you can unlock the value of your data and make informed decisions that drive success. That's a wrap for getting started with data quality. You now know what data quality is, why it matters, and the roles that make it happen. Up next, we'll dive into measuring and monitoring data quality.